Assalamualaikum warahmatullahi wabarakatuh. Now, we talk about application of differentiation. Before that, I want you to meet our member. First, we have Muhammad Azmil bin Halim from PEC 1101A1. Next, you have me, Siti Syuhada Binti Ahmad Nizam from PEC 1101A1. And last one, you have Syatiera Alisha Binti Saffrizan from PEC 1101A2.
Assalamualaikum. My name is Syatiera Alisha Binti Saffrizan. I will start with the introduction. In differential calculus, related rates problem involve finding a rate at which a quantity change by relating that quantity to other quantities whose rate of change are known. The rate of change is usually with respect to time. Because science and engineering often related quantities to each other, the methods of related rates have broad application in this field. Differentiation with respect to time or one of the other variable require application of the chain rule, since most problems involve several variables. Supposedly, related rates are so important because there are so many real-world applications of it, like a snowball melting, a ladder falling, a balloon being blown up, a stone creating a circular ripple, or two people boats moving away from each other at a right angle.
What is the related rates? Related rates is in differential calculus. Related rates problems involve finding a rate at which a quantity changes by relating that quantity to other quantities whose rates of change are known. The rate of change is usually with respect to time.
Next, we have a related rate formula. Suppose we have a two variable x and y. In the most problem, the letters will be different. But for now, let's use x and y, which is both changing with the time. A related rate problem is a problem in which we know one of the rate of change at a given instant. Say x equals dx per dt, and we want to find the other rate y, dy per dt at the instant. The use of x to mean dx per dt goes back to the Newton, and it's still used for this post, especially by the physics. If y is written in the terms of x, y equals fx, then this is easy to do using the chain rule. You can see here the formula. This is find the derivative of fx, plug in the value of x at the instant in question, and multiply by the given value of x equals dx per dt to get y dy per dt.
Application of differentiation. What is differentiation? Differentiation in mathematics, process of finding the derivative or rate of change of a function. In contrast to the abstract nature of the theory behind it, the practical technique of differentiation can be carried out by purely algebraic manipulation using three basic derivatives, four rules of operation, and a knowledge of how it manipulates functions. When do we apply differentiation? We can use differentiation to determine if a function is increasing or decreasing. A function is increasing if its derivative is always positive. A function is decreasing if its derivative is always negative. We use the derivative to determine the maximum and minimum values of particular function. Example are cost, strength, amount of material used in a building, profit, loss, and the others. Derivatives are made in many engineering and science problems, especially when modeling the behavior of moving objects. What are the other applications of differentiation? Linear approximation, maximum and minimum values, and the mean values theorem, Rolle's theorem, and monotonicity.
This is a problem statement. Now I will read the problem statement. A crane is pulling a brake on the ground with a cable that is attached to a puller. The puller is hanging at 10 meters above the ground. If the cable is pulling through the puller at a rate 20 meters per minute, at what rate will the brake wheel push the crane when 125 meters of rope is out? Give your answer in radical. So you can see here. Next is the objective. The objective is to find the rate of the brake while approaching the crane, which is depends on the rate is given using the chain rule.
So let's say the shape, let's say the side given is labeled x, y, and z, which y is constant at 10 meter. So the question gives that dz over dt equals to 20 meter per minute. So the question asks what ds dt is if z equals to 125. So first of all, we must make a formula. The formula that we'll be choosing is Pythagoras theorem, which is a squared plus b squared equals to c squared. I will be using unknown x, y, and z. So the equation now is z squared equals to x squared plus y squared. So if we want to get ds dt, first of all, we must make sure that x is our main. So we make sure that we transfer the unknown and make sure it's s is the main. Okay, since we know that, and we get s equals to z squared minus y squared. So we know that y is equals to 10 meters. So we can replace y with 10 meters. So and we get z squared minus 100. We also know that z squared is equals to 1 over 2. So next, since we know that, we just differentiate it like it's normal. So it is we got here 1 over 2 times open bracket z squared minus 100 close bracket power of negative 1 over 2 times 2z, and we got z over open bracket z squared minus 100 1 over 2. So now we use chain rule, which is ds dt equals to dz dt times ds dz. So we put the number and we got ds dt equals to 20z over z squared over open bracket z squared minus 100 power of, close bracket power of 1 over 2. So the question asks that z is equal to 125. So we replace the number with, we replace the z with 125. So we got 20 times 125 over z 125 times 2 minus 100. So we get, since the question 1 is in radical, so the bot it will be 2,500 over 15/69. So we simplify the top and the bottom, and we got 500 over 3/69 meter per minute. That's all for me. Thank you.
So the conclusion is, first, identify the known variables, including rates of change and the rate of change that is to be found. Like drawing a pictures or representation of problem can help to keep everything in order. Then, construct an equation relating the quantities whose rate of change are known to the quantity whose rate of change is to be found. Then, differentiate both sides of the equation with respect to time or other rate of change. Often, the change rule is employed at this step. Substitute the known rates of change and the known quantities into the equation. Lastly, solve for the wanted rate of change.
This is reference we use to answer the question. That's all from us. Thank you.